When you feel stuck, just remember this.
किसका है ये तुमको इंतजार में हूँ ना देख लो इधर तो एक बार मैं हूँ ना.
So hello everyone, I hope you guys are doing great. In today's video, we are going to deep dive into something very exciting, the implementation of the APB protocol using UVM. So I will be walking you through every important concept step by step. And you know what? I believe this might actually be the first complete video on YouTube that shows the APB protocol implementation in UVM. So you are definitely in for something valuable. So here's how we will go. First, I will introduce you to the architecture. Then we will move on to the code implementation. So you can even use this project as your major academic or professional project. And trust me, it will add a whole new level of impact to your resume. So without further delay, let's get started. So first of all, I am going to show you the architecture of our code. Then we will start coding. Okay. Now see, here we are going to implement our APB protocol. So I am going to show you the UVM architecture. So let's say, sorry for the design guys. So let's say this is your TB top. Okay. So TB top, or you can say Testbench. So this is your TB top. Inside your TB top, you have one component that is, or one entity that is your test. Okay. So this is your test. Now inside test, you have environment. So let's say this is your environment. Okay. So this is your environment. Now inside environment, you have agent. Okay. So inside environment, you have agent, and also inside environment, you have one scoreboard. So inside scoreboard, you have multiple components, that is your sequencer, driver, and then monitor. Okay. Now your monitor and scoreboard are connected with each other. So let's suppose here this is your monitor and this is your scoreboard. They are connected with analysis port. So this is like something, your connection between your monitor and scoreboard. And similarly like this, your sequencer and driver are also connected with a port. Okay. So let's say this is your sequencer and this is your driver. So driver is your like put port. So here, from here you are putting something, and this is your get port, analysis port. Okay. So this is something, the internal things which was there with your architecture. So here your monitor and scoreboard are connected with analysis port, and your driver and sequencer are connected with your TLM port. Okay. Now inside a sequencer driver, we don't have anything. Okay. So this is the, I think, overall rough idea about the architecture. I hope you'll get it. Let me explain once again. I know some of you are like me, slow learners. I'm also a slow learner. So yeah, so let's suppose this is your TB top. Okay. क्योंकि पहले वाले में मेरे को ही नहीं मजा आया. So like this is your TB top. Inside the TB top, you have one test. Okay, so this is your test component. So this is your test component. Drawing सीखनी पड़ेगी यार. And then inside that you have one environment. So inside the test you have one environment. Consider this as a layer. Okay. So inside the environment, inside the test we have one environment. Now inside the environment you have agent. So let's suppose this is your agent. So mark it down as an agent. Okay. So this is your agent, and inside environment you have one scoreboard. Okay. So this is your scoreboard. Now inside agent you have three components, that is your sequencer, then you have driver, then you have monitor. Okay. I hope it is fine. Now your monitor and scoreboard are connected through analysis port. So this is how you can represent the connection of analysis port. Now your driver and sequencer are connected through your TLM port. Okay. So this is the connection between your driver and sequencer. So this is the overall APB architecture which we are going to implement. Okay. Now see, like, let me introduce all these components. So first of all, TB top. So where you are going to generate some clock, run test, and vagera vagera. Okay. Now after inside test, you are going to run certain tests, like suppose you have make 2 or 3 tests, so you are going to run them accordingly. Now inside the test you have environment. So in environment you are building your agent, okay, and you are just configuring the things, or scoreboard, you are building your scoreboard and kind of things, okay. So that's the role of your environment. After that you have agent. So your agent consists of driver, monitor and sequencer, and your agent is of three kinds of natures. One is active agent, another is passive agent, and the third one is reactive agent. We will take or make a separate session on this, okay. So for being now, you can consider like we have three kinds of agent: active agent, passive agent and reactive agent, okay. So we are right now considering as an active agent. So we have active agent. Now inside the agent we have sequencer, driver and monitor. So see, the role of your sequencer is to just as a mediator. So it will like a mediator. So suppose this is your sequencer. Now from here you are generating certain sequence, and it will provide coordination, like your sequencer will provide coordination between your sequencer. Let's say this is your sequence and this is your driver and this is your sequencer. So it just establish a coordination between your sequence and driver. So if you are randomizing something or passing the data, so your sequencer will handle it, okay, and pass it to the driver accordingly whenever driver looking for the data, okay. So that's the role of the sequencer. Now from driver you are going to drive that value or drive that data, okay. Now in monitor you are going to sample that data. Now in scoreboard you are going to check whether you are getting the correct output or not, okay. So for that we are going to make one more component or one more file, that is for reference model. So we are going to use some, let's say, checker in reference model, and the output of that reference model we are passing to scoreboard, and also we are passing the sampled output from monitor to scoreboard. Then we are comparing that output. We are comparing both the output. If it is true, then it is working fine, and if it is working false, and if it is not working properly, so समझ जाओ कुछ तो गड़बड़ है. So this is the overall architecture. Now let's jump into the code. And guys, इतनी मेहनत हो रही है तो एक लाइक तो बनता है. So see, like this is the RTL implementation. So let me just give you the overall like a brief idea about the RTL implementation, because here our agenda is to learn how can we write verification plan, or how can we write the code in UVM to verify our APB protocol. So you are going to get the RTL, like if you are verifying something, so the designer will provide you that RTL. So here in RTL, see, like we have considered one module, and these are all the signal for your APB, okay. So we have considered one P clock signal, then we have P reset, and then we have P select, and then we have P enable, and similarly like we have all this signal. Now here we have considered wait state. So like if 4 wait states, so suppose if your P select and P enable is high, but you have to wait for 4 cycle till your P ready is high, and if your P ready get high, then your transaction will get completed, okay. Now after that we have considered here slave error. So you will get slave error if your address is क्या भाई इन्होंने क्या लिखा है, मेरे को भी देखना पड़ेगा. डिज़ाइन मैंने नहीं बनाया यार, नहीं बनाया तो मैंने ये, पर बहुत पहले बनाया है. ठीक है, कहाँ है भाई. Yeah, so you will get slave error whenever your address is 10, or you can say 16 in decimal, or 17, okay. Here I have noted in hexadecimal, so that's why I have written 10 and 11. So whenever your address is 10 and 11 in hexadecimal, so you will get a slave error, okay. I think it is fine. Now let's jump to the main or important part, that is our verification. Just hide this design. Yeah. See, I have already written that code, but I'm going to show you the each step how can you proceed, okay. So don't just jump on the code, and don't just like watch all the code. Just get my idea like how I am representing, and the similar way you have to follow, or you can say the similar approach you have to follow while making any test bench, okay. So first of all you have to add these two macros, okay. So tick include UVM macros and tick include APB package. So why I have used this? So first of all I have written here tick UVM macros. So UVM macros will allow to use all the UVM stuff, whereas in another line, in next line I have written APB package. So in APB package file, so see here I have created one APB package file, so where I have taken the old file in sequence order. So instead of writing in another file, in all file like tick include, I have just created one separate file where I have written all this file. Okay, so that's why I am inserting there. Now I have imported that file. Now here see, this is the main part, this is your TV top. Okay, so here I have considered one clock and then reset. So here I have considered one clock. Now I have generated the clock and also I have configured my reset. Now here I am connecting my duty signal to the interface. So see, like here we have actual interface and in class you have some virtual interface. So you know why, what is the need of using virtual interface in class? So if you knows the reason, so just write down in comment, or otherwise I will just mention that in comment. Okay, so after that I have used config db. So you can just write it like this, you can follow the same flow. Okay, so after that I have used config db. So here the intention of using that config db is to just set some interface and we can get it by any component. Okay, so here that's why I have written we are going to get any component. Okay, now here I have used dump file in order to see the waveform. After that we have run the test. So since right now my test name is APB test, so I have run that test. Okay, so this is your TV top. After writing this TV top, your approach is to write the build phase of all the component. Okay, so see, this is my flow. If you are like know some flow, so you can carry on with that, but if you are like new here, so you can just follow my flow. Okay, it will be give you like a better understanding. So after that, see, after writing the TV top, you can jump to the APB transaction. So after writing the code of TV top, you can just directly jump to the APB. So this is my APB transaction. So here I have extended my APB transaction from UVM sequence item. Then I have here like I want to randomize only my address and data and P write. So why the rest of the thing will be as it is. So PR data as it is because we are going to get data from the address which we are already generated. Okay, now P ready. So P ready we are going to insert from the slave and it will be inserted by the slave. P select, so we are not going to randomize our P select or P enable, and the rule for P enable is that if your P select assert, then on next clock cycle it is mandatory for your P enable to be high. Okay, now P slave error, it should also be not randomized because it will be given by the slave, so that's why I have written like this. Okay, now after that I have used constructor. Now since your UVM, this like your APB transaction or UVM sequence item is an object type, so it doesn't have any parents, so that's why we are using here single argument. Okay, so here this is the name of your class, or you can write anything, you can write kit2 also. Okay, but मेरा नाम मत लिखना, तुम मुझे फंसा दो कहीं. So here I have written just APB trans. Now here I just want to see this field, like whenever you want to use see some fields, like whenever you want to use print method, so you can get all this field on your display. Okay, you can able to see all this field on your display, so I have written that. Now I have used constraint. So right now I am just looking for the constraint address 0 to 1, because see, like I want to check that whether I am getting our data correctly or not. So that's why I have just restricted my address from 0 to 1, and I also use soft keyword. So here the intention of using soft keyword is I can override if I want. Okay, so while randomizing, if I want to override this constraint, so I can. Okay, now after that I have written one constraint for the P write. So see, like I am expecting that my P write should be high for 70% and P write should be low for 30%. Okay, so that was my expectation. So see, this is your flow. Like you can first write your TV top, after that go with the APB trans. After writing APB trans, you can jump into the APB sequence. So let's see what I have done in APB sequence. So in APB sequence is also a kind of object, so it can be extended by UVM sequence and it's an object. Now see, here I have taken one instance of APB trans. Okay, so this is our APB trans, that is our sequence item. Okay, so we have taken one instance. Now this is your constructor. I have like explained you why constructor we are using and why there is only one argument. Now see, task body. Now since APB sequence, or you can say UVM sequence, is not a component, so here task body is there, and if it is component, so we have 9 predefined phases in UVM. Okay, that is build phase, run phase, connect phase, whatever. Okay, but here since it's an object, there is no such phases for object, so we have written task body. Now here we are randomizing our transaction 10 times. So here you can see we have used repeat loop, so we are expecting that we should randomize our transaction 10 times. After that we have used start item. So start item, like, it will wait for the sequencer. If your driver are looking for some transaction, then they will tell to your sequencer that they are looking for the transaction, then your start item will get invoked, otherwise it is get blocked. Okay, otherwise it will be in blocking mode. So after your driver initiate so whenever your driver request for the transaction, start item will be invoked. After that you are randomizing the stubs and finish item, so you are ending that. Okay, so so start item, after that you have randomized, and then finish item. Now after that you have used transprint. So why you have used transprint? So just to see that the whatever thing I am sending is going correctly or not. Okay, so for that reason I have used here trans.print. So see, after implementing this APB sequence, you can jump to the APB sequencer, and APB sequencer is the most simple thing in your entire architecture. Okay, so the role of APB sequencer is to just pass the sequence from APB sequence to APB driver. Okay, now here in APB sequencer, since it's an component, so here we have used tick UVM component utils. Now since it's an component, so here it required 2 argument in their constructor. So first argument is string, and the another argument is UVM component and parent. Okay, now build phase is not required here, but I have used, I don't know why, but yeah, it's not required. Okay, so only thing you have to write this in sequencer is that only. So this is the only thing you can write in your APB sequencer. Now the main part comes, APB driver. So before starting this APB driver, let me give you the idea of APB driver. So your APB driver is nothing but it will pass the transaction from sequence to your DUT, or pass the transaction from sequence to your interface. Okay, so it will just like, you can say, passer, or it will drive the data, you can say. That's why its name is driver, I think. Okay, so here we have used APB driver class, and inside that, since it's also an component, so we have used tick UVM component utils. Now virtual interface. So see, like I have already explained you why we are using virtual interface. नहीं किया था क्या? कमेंट में लिखने बोला था ना? हाँ, चलो मैं कर देता हूँ. See, since your interface, or you can say since your actual interface is a static entity and your class is dynamic, here you have used your interface in class. So class is your dynamic entity, whereas your interface is a static entity. So you cannot directly use a static entity inside the dynamic entity. So that's why we are using virtual. So that means this interface is pointing to the actual interface. Okay, so that's the reason of using virtual. Now here we have considered one transaction handle. Now here we have considered one transaction handle request. Now since all this part is same, like we have considered one constructor. Now in build phase, so now here the role of build phase come. We are getting the config DB. Okay, so we have set from the TB top, and now here we are getting the interface, because we have to connect it to the interface, because your driver is going to drive the data to interface, so we have to connect these. So that's why we are getting the interface here. Okay, now after that we have run phase. So in run phase we are calling sequence item port. So see, this is the default port which was there in UVM source code. Okay, so you don't have to declare that, you just have to use that. So we have used sequence item port, it's an TLM port. Now we are using get next item. So it means we are telling our sequencer that we are looking for some transaction. So if you are using sequence item port dot get next item, so you are initiating some request, or you are initiating some request that you are looking for certain transaction. Okay, so if you will get the transaction, then you can call send to duty. Okay, so I have called send to duty after getting the transaction. So see, like I have called the send to duty task. So this is your send to duty task. So in your send to duty task, here you can see, like we are sampling or we are considering the transaction at the every posage of clock. So we are getting the P address, we are getting the PW data, and we are getting the PW write from your sequence. Now we are making our P select 1 and P enable 0. See, the reason is that because whenever your P select is high at that phase, or you can say at that region, you are configuring your address and data information, but you are sending the address and data information whenever your P enable is high and P ready is high. So see, here our P enable is 0. Now it is mandatory for your P enable to be high on the next clock cycle. Okay, so on the next clock cycle P enable is high, but we are waiting for the P ready to be high. After that P ready is high, or you can say once your P ready is high, you are making your P enable 0. That means like you have completed your transaction. Okay, or you can completed your transfer. Okay, so I hope you get the point. Now this is your like send to duty task. After that send to duty, we are calling item done. So that means we are giving the response that we are done with the item, we are done with the transfer. If some transfer are left, so you can continue, otherwise it will be over. Okay, so that's how we have used. Now see, here you can see we have used forever begin, and in sequence part we have used simple repeat. Here you can see we have used repeat 10, and in all component, in rest of all component, like in monitor also, in scoreboard and vagera vagera, you can see forever. So the reason of using forever is like that, if we are passing some data, so we are continuously monitoring that, or we are continuously looking for the data. So from sequence we are repeating some data, or we are randomizing some data. Some, let's say we are randomizing 10 data, so we are looking for at every cycle, and we are continuously looking for it. And if it get over, so you will get automatically, you can drop your objection and you will get out of the loop. Okay, so here we have used forever loop, so we are continuously monitoring that. Okay, so that's why we have used forever loop. And I hope you get the idea of using item done. So simply we are responding them that we are finished with the transfer. Okay, now if you want to give some, or if you want to add some next data, so you can ask for the get next item, otherwise it's done. Okay, so this is the role of your APB driver. Now APB driver, see, here we have connected our actual request to interface. So you can see here we are connected with the interface, and this is your clocking block. So instance of clocking block, and inside that we have address. Okay, so we have connected that. After this driver you have monitor part. So monitor, the role of your monitor is to sample your data from your interface. Okay, so the thing which we have done in driver, the similar thing we are going to do with a monitor. So here in monitor we are going to sample the data. Okay, so the role of monitor is to sample the data. Now here we have used analysis port. I will show you the use of this analysis port. Before that, here you can see, here also I have considered one handle of the APB trans, and also the handle of the virtual interface. Okay, now here this is your constructor. Now in build phase we are getting the thing, because see, like in driver or monitor only you are getting this interface, because in driver you are passing something to the interface, and in monitor you are getting something from interface. Okay, so that's why we have used interface. Now after that, in run phase we have called get from duty. So in get from duty we are waiting for the P select, P enable and P ready is high. If all these three is high, then and only then we are sampling the data, and it is fine. No, like if all these three high, then and only then we have to monitor that. Otherwise, whatever it may be, there is no reason to continuously monitor. Okay, so we are monitoring only if all these three signal is high. So if all these three signal is high, we have taken that data, or we are collecting that data from the interface and giving it to the transaction. Okay, and saving it to a transaction, you can say. Now after that, see, if your P write is high, so that means we have to write the data inside the transaction memory. We are writing data inside a memory, and if your P write is low, that means we are reading data from a memory. Okay, we are reading data from a memory, and if p write is high, that means we are writing data inside a memory. So after that we have use AP port. Now here the role of AP port, this is analysis port. Now see, analysis port is nothing but it is used to broadcast. So here from monitor you are broadcasting your like a transaction to your scoreboard, and also you are passing it to the reference model. Okay, so suppose like see, if you want to broadcast something, so you can use analysis port. So that's why I have used analysis port here. So that's why you can see here the implementation of the analysis port. You can implement it or your analysis port like this. Okay, so here my intention was to broadcast that, so that's why I have used that analysis port. So now after monitor you can use or you can write your agent. So in agent we have built all these three components, and in architecture also we have seen that like in agent all these three components are there, so we have to build them. So we have built them. Now we have connect that, like see, in agent we have to connect all these things. So let me show you the architecture first. So see, in agent, so let's see, this is your agent. So there is a connection between your sequencer and driver. So in agent you can see we have connected our sequencer and driver. Okay, now since your driver handle it driver, and then we have sequence item port dot connect. So sequence item port is an inbuilt method. Okay, so we have connected that. Now after agent we have environment. So in environment we are building our agent. So see, again see, now in agent, we in environment we have agent. Okay, so we have to build that agent in order to use it. So see, in environment we are building our agent. Also in environment we have scoreboard, so also we have built scoreboard, and I have used reference model. So here is here the use of reference model is that it will get the output and store it in memory, and then we are passing it to scoreboard and then comparing it with the actual data. Okay, so it's sort of like we are writing some checkers. Okay, so that's why we have used one reference model. Now in connect phase we have connected our monitor to scoreboard. I have shown you in architecture. See, like here your monitor and scoreboard are connected in environment. Now your monitor and reference model is also connected in environment, and then your scoreboard and you can say reference model are connected in the environment. So this is the three connection. Okay, after the environment you can write your test. So in test I am doing nothing but since it's a component we have used all that. Okay, now here we are building our environment as well as sequence. Okay, so here we have taken the handle of sequence, or we are see, like here we have builded that sequence. Okay, we have built that sequence and environment. After that in run phase we have used raise and drop objection. See, the use of raise and drop objection in here is like that. Whenever you are using sequence, that is the handle of your actual sequence dot start method, and this is the blocking method. Okay, so now here you are giving the address of your sequencer. So sequencer, if in order to reach to the sequencer you can go through that environment dot agent dot sequencer. Now after see, whenever you call this method, so it will invoke your task body which was there in sequence. Okay, so if repeat 10, so that means if 10 transaction has been completed, so drop objection will come, so it will overall terminate your simulation. Okay, so that's why we have used drop objection. If we are not doing so, so we have used forever loop, so our like simulation will go till infinite. So that's why we are using here drop objection. I hope it is clear. Okay, so that's why we have used here test. Now this is the define file, you can write it or not, it doesn't matter. So here I have written define or and all. Okay, now this is the interface. This you can write at the beginning. Okay, so I just forgot to show you. So here in interface I just written all this signal. Okay, I have written all that signal and clocking block. So here the role of clocking block is to just avoid the race condition. So this is your clocking block. So here in at driver side, your p select, p enable, pw data, p address, and p write and p reset, these all are the output signal. Because see, like your p select is going from, you can say, your master to slave. Okay, so it is output, like it is exerting, or you can say it is like going something. So if something is going, then you can denote it as an output, and if something is incoming, so you can write it as an input. Okay, and for monitor all things are input because monitor are sampling the thing. Okay, so this is overall code and architecture for your APB. Now how we are make suring that and how we are confirming that whether it is working properly or not. So we have written reference model and scoreboard for that. Now let's go to the reference model. So see, in reference model I have considered one associative array. See, this put is I have used to just send after this, to just send my data or transaction which I have predicted to my scoreboard. So for that I have used this put. Okay, now here I have using that constructor, and then I have taken one handle, that is reference trans. So the reference trans, and then I have just created that. Now if our write is 1, so that means we are writing something inside the memory. So here you can see we are writing something inside the memory, and else if write is 0, so we are checking that. We are checking that if address is not exist, so we are writing it 0. If address not exists, so we are not going to read anything. So in that case we are making it 0, and if address exists, so we are reading from that address. Okay, so that's the role of your reference model. After that I am just using put. So can you just imagine why I have used foxo and none? Let me tell you. So your put is blocking method. Now I have to use here because I have to use here because क्या इधर ही मुझे करना था. And since your function is non-blocking, so in order to make it non-blocking, I have used this foxo and none because it will just keep this process in background. Okay, so that's why I have used this reference model. That's why I have used here foxo and none. Okay, now we are passing this to our scoreboard. Now in scoreboard we have considered two queues. Now one queue for to store our actual data and another queue to store our expected data. So we are storing our actual and expected data, and we are comparing after that. So since if both the queue size is greater than 0, that means we have get both the data. So after that we are getting it into some actual and reference expected handle. So we are comparing. See, so if your p write is low, so that means you are reading some data. If your actual data is not matched with the expected data, so here we are printing mismatch, otherwise it will be work as it is. Okay, so this is the overall flow of your APB architecture. Okay, so I hope it is clear. So I am attaching this EDA link in the description. So if you want to use this for your project, so you can use this, but go through this each component. Okay, because see, you will get the idea how to implement this. Okay, now since people are doing it for people are charging thousands of rupees for this simple protocol, but I have explained it as a free, so you can just take help of it. And if you feel any doubt or query, so you can just connect with me. Okay, in comment or on my LinkedIn handle or wherever it may be. Okay, so I think that's all for the today video. If you have liked this video, so just make sure to like that and just hit that subscribe button. Okay, thank you.